Welcome, everybody, to Channel Vision Magazine, this webinar featuring our good friends Dell Technologies. In this presentation in particular, we're going to learn all about the future of artificial intelligence. I'm your moderator, Brady Hicks, the managing editor with Channel Vision Magazine, and joining us today, your host from Dell Technologies, his name, Bronze Larson. How you doing today, Bronze?
Very well. I really appreciate the opportunity to speak with you today, and looking forward to some of the post-talk engagements and be able to maybe answer some of the audience's questions.
Yes, it's going to be very engaging for sure, and it's such a topic of interest for so many people. After CVX, we actually did a survey, and artificial intelligence was one of the topics that kept coming back for us as a huge focus for the future. Now, with that, Bronze, I'm going to turn it over to you.
Yeah, thank you very much. So my name is Bronze Larson. Formerly, I am a applied mathematician. I have a PhD specifically in artificial intelligence, and I've been working in this space for, gosh, 20 plus years right now. And the thing that's neat about AI is it really is cross-discipline. So my career has spanned both commercial and government customers, and really has crossed almost every scientific discipline, from biology to radar to communications. AI really is applicable to almost anything on Earth. I've been at Dell for about 5 years now. I started my career as the AI strategy lead, helping to kind of point to where AI is going and hopefully lay out some strategies for what we may be able to do to get ahead of it. Most recently, I've been part of an ecosystems team, which focuses on diverse scientific disciplines as well. I was leading the AI part of it. And this is out of the office of the CTO. Now, the thing that's kind of intriguing about the CTO's office is it has a little bit of a different charter than the rest of Dell, in the sense that we really are very forward-leaning, looking a little further out into the future than most. So when we talk about the future, it's not next quarter or even this year. It's really, 5 years out, 10 years out, even 15 years out. Our CTO, John Rose, he often says, I don't want to get caught flat-footed. I don't want to miss the next internet. So our goal when we look to the future is really to identify the real disruptive changes which potentially could be out there, to hopefully allow us to develop strategies to get ahead of it, whether it's to prevent disruption or to actually identify opportunities that might enable some significant growth. So today I'm going to talk a little bit about that, the future of AI. But I'm going to start off and just level set, where is Dell with respect to AI right now? Just a couple charts to sort of let you know what we're doing at Dell with AI and what Dell looks like. And then I'll turn my attention to, where is AI going? So to start off at Dell, we focus on a lot of different disciplines, from 5G, edge, data management, cloud, security, as well as AI. And the neat thing about AI is it's probably the most horizontal of all these different capabilities and technologies, in the sense that it's not only affected by them. So for instance, data management affects AI, but AI is often used in data management as well to do optimization. So it's affected by and affects these other disciplines. And it really is very horizontal and applicable everywhere, which is why it's such important technology. At Dell, we have three broad categories. There's a fourth one that we've added. I'll touch on in a second. But AI in, on, and for. AI in is where we put AI in our products. It's often maybe something as simple as optimizing the heat signature within a product. Customers don't necessarily know AI is there, but they benefit from a product that maybe is running faster, cleaner, quieter, and might last longer. So they benefit from a more improved product, but they don't necessarily know AI is actually running under the hood. AI on is where are the services and the technology and the hardware, that infrastructure we actually build to allow our customers and clients to realize their AI dreams on our technology. So this ranges from data management tools, accelerator enablement. So, working with GPU servers and AI system integrators. But again, the point here is we are simply trying to work with customers to meet their needs, their experts who want to run systems and need our infrastructure to be able to do that. But we're not just sellers of AI, we're also consumers. And so AI4, these are the areas that we apply AI for us. It could be for identifying sales and marketing opportunities, targeted marketing. It could be even for things like, predictive maintenance or predictive product failure or parts failure, so that we can make sure we properly stock our repair rooms with the right equipment and the right personnel if we anticipate that there could be a surge in a particular maybe part that is going to be failing. And allows us again to hopefully provide a better service to our customers by fixing their product, returning it more quickly, and having a better overall experience in the long run. We have another one called AI With, which we're just starting to expand on, and that comes out of, in many ways, the ecosystem team that I'm part of today, where we're really looking to understand how we can operate better with our partners, and really get network effects for improved overall experiences, products, and services for everyone involved. At any given time, we have a few hundred different AI projects going on within Dell. This was a snapshot I took a while back. There was a little over 500 different AI projects in various stages of development. I think the most recent snapshot identified about 900. And so we have a couple thousand AI experts and practitioners that are helping to lead these efforts and drive the business and the research into these and the product development. We work across pretty much almost every single vertical that you can imagine, from manufacturing to healthcare, defense, media, entertainment, retail, energy. And so we have a lot of different clients and a lot of different partners within all these different sectors of business. And our customers that we work with, we're pretty adept at working with advanced customers and kind of novice AI customers, and to kind of bookmark or bookend these two different kind of type of customers, the personas out here. This is an example of one customer we worked with. It was actually a country that was looking to increase their Olympic standings. And they happen to have a lot of real high-end, top-notch AI expertise in-house. So they were looking for an AI on solution from us to build an actual data center that could house the data they collect, do the AI and analytics themselves, as well as having edge devices and systems that could be deployed near the actual athletes that we're actually training around the world. For example, in this picture up top, we worked to integrate drones that could fly next to the crew, the rowing team, and actually capture their video, turn it into these stick figures, which could actually then be measured and run analytics against to see if they can improve their overall performance in the Olympics. So this was an example of a very sophisticated customer that knew what they wanted. They're the AI experts. We're there to enable their dream. At the other end of the spectrum, this was a customer that didn't know how to spell AI and didn't want to know how to spell AI. They had a problem with their self-checkouts where people were taking a product that maybe was cheap, pack of gum, and they would hold the barcode, the SKU, in front of a more expensive item, like in this upper right picture, a bottle of wine, and they'd get a $40 bottle of wine for $1. And so we worked with them to basically add cameras and an AI system that could identify the actual products that were being purchased visually, so we could correlate that against the SKU itself and flag inappropriate behavior. So again, this was something that they had a problem to solve. We came up with a solution. We integrated the solution and deployed this AI system, including the hardware modifications to the self-checkouts globally and the entire infrastructure to be able to update the model with new products that they sell within their store. This was a major retailer, and this was deployed globally. So again, the idea of working with customers who are very adept at AI and those that have literally zero knowledge, were really equipped to be able to handle anything in between there. But as I mentioned, the office of the CTO, our goal is really the future, far out. And so when I looked at this, I took kind of a three-pronged approach, which was, what's going to be the driving force? And there's kind of three areas: algorithms, hardware, and I'll say tooling or making it easy. And what I mean by that is sometimes it's actually the algorithms. There's maybe a capability, a piece of intelligence or something about the current AI algorithms that's lacking. and it drives the need for more improved intelligence, more better answers overall. And that's the driving force. And if that's the case, then these new algorithms sometimes need new hardware and new tooling to enable the new algorithms. So the algorithms sometimes are the driving force. But that's not always the case. Sometimes it can be hardware. And that accelerator infrastructure, that's a perfect example of the GPU space, which was something that, I'll talk on this in a little bit. We realized that this new piece of hardware was potentially able to enable a lot of edge processing for AI. But I had a program to kind of focus on this about 20 years ago. And what we realized is that the algorithms that were out there had to be modified to make use of this new hardware. So in other words, the hardware advancement drove a shift in the algorithms and the way that we would actually host these algorithms on this hardware. And then the tooling wrapped around that and followed as well. But on the other hand, sometimes it's something, I call it the make it easy task. It's something a little more intangible. Maybe it's not the fastest solution, it's not the best intelligence, but maybe something is just it clicks so well with end users that it becomes the standard. In some ways, I think of the hyperscalers kind of falling into this with respect to AI. They kind of fall into that category. I mean, if you use their tools, they're not necessarily the fast by any means. They're not necessarily providing the best AI solution that is out there, but oh my gosh, are they easy to use. I mean, my elementary school daughter last year trained up an AI system for a class project using some of the hyperscalers tools. They're that easy to use. And so, they can often grow and become the standard and really be the driving force. But my feeling is that it is the algorithms that are going to be the driving force. And the algorithms have evolved in these different waves, which are on this banner here. The first wave, goes back to the 60s, 70s, and 80s, and is still around today. And I'll touch on that in a minute. And the second wave was really what we're in right now, which is the neural net, deep learning, deep fakes, even the Gen AI stuff today. It's all based on these statistical methodologies. And there are some cracks forming in their performance, some limitations that are leading to a new way of thinking of AI, which is known as the third wave or the next wave of AI. And that's what I really wanted to dive into. Now, is this just me? Am I just sitting here saying, yeah, I think this is the case? There's a problem with AI today. There's some shortcomings. Really, is that just me? Well, not necessarily. I tend to look at a number of different places. I kind of stay up to date on the advances in AI. And one of the areas that I spend a lot of time tracking is an organization called DARPA, the Defense Advanced Research Project Agency. They are the largest venture capitalist firm on the planet. I mean, their budgets are published at, billions of dollars a year, but, if you take into account their kind of unpublished budgets, it's virtually unlimited. They are the de facto leaders in terms of funding AI and developing AI and deploying real usable AI systems on Earth. No one has come close. They've been doing this since 1960. And pretty much every AI advancement has its roots and its tendrils connecting back to DARPA. And one of the biggest funding offices there is called I2O. And a recent director was asked, so this is one of the top funding development research wings on Earth today. And the director was asked, well, what do you think of AI? And his comment was, well, artificial intelligence is not that intelligent. Matter of fact, neural nets, they're just spreadsheets. And I actually love the second quote. I use it quite often because, there's a lot of hype out there. People that get overly excited about AI, it's the next gold rush, or people get overly fearful of AI, that it's going to take over the world, the rise of the machines. And I like to sometimes say, oh my goodness, really? You think that Microsoft Excel is going to take over the world? And it kind of causes people to pause and then kind of, they furrow their brow and they say, what did you just say? And it often allows us to maybe have a little more of a grounded conversation about some of the strengths and weaknesses. And it's a kind of a nice way to sometimes quell some fears as well as some of the excitement and really be able to take a grounded approach to what AI is, what its strengths are, and what its weaknesses are. But it's not just DARPA. Some of the de facto leaders out there, like Geoffrey Hinton, he's known as the godfather of deep learning, he was asked, so what's next for AI? His comment, well, it's probably time to throw it all away and start again. Even some of the prognosticators, the general purpose, high level ones, the 451, McKinsey, Gartner, Gartner puts out these hype cycles on a regular basis. You've probably seen these. And this is just one of them. And by the way, they move these words around. You could find another variation of it where some of these are moved around a little bit, but it's kind of interesting. This was one I just grabbed on algorithms. And if you look at some of the words there, ethics, deep learning, natural language processing, machine learning, intelligent applications, chatbots, computer vision, autonomous vehicles, semantic search, even generative AI. They have those all kind of falling off this cliff into this trough of disillusionment, showing that there's a lot of hype there, but people are starting. We've been really kicking the tires on this for a while, and I think we've started to find some of the warts, some of the functional boundaries of it, and people are starting to kind of realize, well, maybe it's not all that I thought it was going to be, but what can I do with it then? So it's a good place to be. It's part of the natural evolutionary process of the technology. So let's skip this one here. So what do I mean by this? Why is it that people are having, maybe concerns? What are these concerns? Well, one of them is, and this is probably the biggest one, current AI, neural nets, deep learning, it's non-adaptive. And what I mean by that is it really can't operate on stuff it's never seen before. And examples, let's say I trained up a neural net to recognize dogs versus cats. It might be able to get good performance on that, but now you introduce a fish and it doesn't know what to do. It might classify it inappropriately as a dog or cat, or just fail. And that's really a dangerous characteristic in a lot of applications where maybe you need to be able to identify new stuff because you just don't have all the data to realize all the different scenarios that a system might be presented with. You can imagine autonomous driving. I mean, my goodness, if you had something big missing, you can't have a car just fail. You really need it to be able to adapt, maybe gracefully change, or even gracefully degrade to the point that it makes a decision to sort of back off and slow down. This one's kind of surprising, lack of data. And I actually have a chart after this specifically on this because this one usually I get a lot of questions on. So I made an extra chart to kind of just talk a little more about that. But yeah, we're actually running out of data. And as you know, neural nets are data hungry. So that's a problem. And I'll talk a little bit more of that. I'll postpone a little more detail of that to the next chart. But we are having a problem with data right now. And as a high level, it's because although there's more data, there's not more information in the data. And information is actually what neural nets need, not more data. They need more information. They're also highly prone to errors. I mean, you can look out and you read these articles about, oh my gosh, this great application of X, Y, or Z using AI, and then they'll say, 90%, 70%, accuracy. Well, those are pretty abysmal performance metrics. Maybe not for something like recommending a blouse or a Netflix movie. I mean, so what if you get, 1 out of every 10 wrong? A person goes, that was okay, that movie, or, I kind of like the dress, but I'm going to go, look some more. The impacts aren't that, really detrimental. But imagine you were trying to use it to predict disease. You need pretty small false alarm rates. You can't have these things fail because, that impact is pretty big. And they just have a real hard time, these statistical methodologies of really pushing the error rates down small enough. Now, the unexplainability that's a little bee in my bonnet, just because I'm a mathematician. As a mathematician, I like to understand where every single bit goes through a system. I don't like to have a single bit unaccounted for. And unfortunately, neural nets are these black boxes. Mathematicians can't even model a single layer of these neural nets or even know why a single neuron is firing. We can't explain that. And that's a little scary because that means that there's always cases out there that could just behave in very unpredictable manners. And that's a scary thing for a lot of applications out there. As you guys are aware, governance, a lot of the laws that have been put in place and are actually increasing, they're actually quite difficult to stay on top of. I mean, even at Dell, we had a product we deployed across the entire company, and later on we found out it didn't meet some legal requirement, and so we had to scuttle it. And even with our teams of lawyers tracking this, actively, it can be difficult to stay up on all the changing requirements. Compute. There's a lot that you can see online about this. I mean, you hear about ChatGPT costing $1 billion for training, or taking up so much power that it's has sustainability issues. And that's actually a real problem out there, and it's getting worse. The GPUs, which are the primary kind of compute element, they're sort of reaching the limits of what the design they can do. So that's why you just see this ganging together of more and more and more GPUs to try to solve the problem. And these GPUs are not designed for AI. They just kind of are good enough. So it's really a non-optimal solution that's starting to cause some real concern. And just overall, the complexity. A lot of users who just use tools out there, they think it's sort of easy. Pump data in, press a couple buttons, and it comes out. But really understanding why something's operating the way it is and being able to get over, drive the error rates down, it really takes serious AI expertise. And there just aren't a lot of AI experts out there that really truly understand how to develop and deploy these systems to meet the type of requirements that you see out there. And an example, I used to be involved in the drone business. And remember when drones were going to deliver all the packages, and they couldn't meet a lot of the legal requirements to actually make it a deployable system. So it's hard to do. But the biggest reason why we need another wave or something different is just current AI. If I use the DARPA example, it's just a Microsoft Excel spreadsheet. That's not a human. It's not AGI, which is artificial general intelligence. I mean, we as scientists are always wanting to push the boundaries to try to create that human-esque experience, and we're far, far from it. So, we realize neural nets are fantastic, but they are a little bit lacking if you put it against the metric of a human being. So something else is needed. So just to come back to this data one, just because I get so many questions on it, this is a little cartoon graph I made where the x-axis is the amount of data, with basically the right, things moving to the right, meaning more data, a lot of data. And what happens is the AI performance is not necessarily increasing. It's sort of flattening out, even though we're pumping massive amounts of data into these systems. I was actually out at a meeting with the government, and they were bemoaning this problem. They collect all the data on Earth, and they were just saying they're pumping it into their systems, and they're just not getting much more out of it. And one of the examples they threw out is just to kind of high level was 10 years ago Facebook was dominated by a bunch of soccer moms posting pictures of their kids. Well, 10 years later, Facebook is dominated by a bunch of soccer moms posting pictures of their kids. So humans are kind of creatures of habits, and we're producing a lot of the same data. And although you have more data, the data tends to all be correlated, statistically dependent upon each other. There isn't more information content within the data. And so you're getting these diminishing returns. I was even out at San Diego Supercomputer Center recently, and someone brought up something about ChatGPT going to 100 trillion features, and that little giggle broke out in the audience about, oh my goodness, where are they going to get the information to make that work? And the audience, the commentator, the speaker kind of laughed and said, no, I know that's a separate topic. Yeah, no, I know it's you have more features, but if you don't have more content, it becomes a bad situation where performance can actually degrade. To kind of drive this home, I actually worked on two different approaches to submarine detection in my past movies I worked on, movies being projects. And there were two approaches. One was a neural net approach. Let's seed the ocean with billions of cheap biodegradable sensors. These kind of low fidelity sensors, they're just everywhere. So lots of data, and it's a neural net approach to see can you combine all this information and detect submarines. And the other was, let's develop a single highly sensitive sensor with new algorithms, new hardware. And I can tell you that, that's the one that's still going strong, and the other didn't live up to it, because more bad data doesn't increase AI performance. So a bunch of cheap sensors making lots and lots of data that was sort of all correlated, it just didn't wasn't up to snuff to actually really achieve the goals. So better algorithms are really where you're going to get the bang for the buck. So, to kind of drive this home, some of these points again, I touched on, kind of this drone example. And you see, this is one of the things you see online a lot. You see a lot of really, kind of these demos, these parlor tricks, people saying, wow, look at this. And although they may be at times statistically impressive, the fact that these are black boxes and they're based on statistics means there's going to be failures. You can't get away from that. And so even if you drive the error rate down, like in this, I was involved, I ran a drone lab, And we were doing drone swarms. So I'd have these swarms of drones flying through trees and avoiding objects and tracking objects, and false alarm rates, which were, 0.00001, 1 in a billion, But the problem was these drones had so many different types of sensors surrounding them, these LiDAR, radar, EOIR, et cetera, sensors in all 360 degrees. They were making so many decisions every flight that it would surpass that 1 in a billion problem. So I could show these videos of great technology just doing amazing things, but if every single flight I had over 1 billion different decisions that had to be made, then that 1 in a billion error would rear its head, and it would result in basically every flight crashed. So again, statistically impressive, amazing technology, but it's pretty hard to make it a real system. So that's a challenge with neural nets. It really is. The other thing is they're just easily confused. There's a lot published on this. This is an example on the left. It was training up a system to recognize car logos. Do a really great job, great performance. But then minor perturbations, like a few raindrops, that's what the right picture is showing, all of a sudden cause the system to fail miserably. That's a really dangerous situation. That's hard to account for all the different potential noise elements that might be out there. And that's, again, a real problem that, you can't always account for all these types of errors that can kind of rear their head. So again, there's real challenges for real systems, not for something like recommending a Netflix movie, but when you're talking about something more that has more impact, you got to kind of be careful about these false alarms. But the biggest issue is the abstraction. I've mentioned this kind of as the first biggest problem. And the example I have here is, let's say a neural net can recognize that, look at that picture and say, that's a dog and that's a washing machine. It has trouble abstracting and saying, I wonder if that dog could go in the washing machine, and then reasoning and saying, that would be a bad idea. And that's a very human characteristic that's very important for, systems to be able to sort of think outside what their training set posed, because maybe, data sets just don't cover all the different potential environments that an AI system might be exposed to. And, you need something that's able to adapt to that, much in the way that humans do. So, how do we do that? How do you think about it? How do you just even kind of break your mindset from the neural net concept? And the thing about neural nets is what they're really modeling is the human brain evolution over tens of millions of years. They're not measuring or modeling human learning. An example of that is neural nets need lots of data to recognize a single object, but humans don't. I mean, people and animals, we don't need 1 million samples in order to recognize an object. I mean, I can show a little kid the letter K drawn with a pencil, and that kid will recognize that letter K for the rest of their life, whether the K is upside down, turned sideways, even inverted, red, green, blue, fat, Times New Roman, Arial, even if a cloud looks like the letter K. And then if I showed them a different letter that they'd never seen before, like the letter P, they'd probably say, well, I haven't seen that before, but you know what? Kind of looks like it's part of that alphabet thing you just described, and it probably represents a different phonetic sound. So humans were able to adapt. So learning in humans is completely different from neural nets. I mean, if I were to use an analogy of neural nets, because neural nets are modeling human brain evolution over tens of million years, the equivalent of if our brain operated like a neural net would be every time I look at something new I've never seen before, my brain would dissolve, and then in 10 million years, it would basically, re-evolve to recognize this new object. And then I look at something new and it would dissolve and then take 10 million years to, kind of train up again. And that's not how the human brain works. And I think it's neat about humans is we are incredibly creative. We can invent things that don't exist, a Pegasus or a unicorn, or J.K. Rowling's invented Hogwarts. She didn't have to go to a school for magicians to invent Hogwarts. So again, people are creative. People can invent stuff that's never existed on Earth before. And that's something that neural nets struggle with. So to kind of summarize these three waves, the first wave in the upper right, it was really kind of popularized in the 1980s with, robotic, machines that just captured something and automated something a human would do. A video game, playing a game of checkers. I mean, the rules are pretty simple. You can encapsulate that in an algorithm. An ATM machine, human goes and gets money from a human teller. Oh, they're able to kind of automate that and ask a few questions, walk someone through a little screen and get the money they need. And so that's kind of what was the first level of AI and still used today, very powerful. Stochastic knowledge on the left there, that's where we are today. That's neural nets. And the thing is, it's very data hungry. So it's based on data. And yes, it's good at learning. That's kind of its strength, but it doesn't adapt, which is this third wave in the bottom right. And so the characteristics that I would use to describe the third wave are this ability to adapt, the fact that it doesn't need any data, which is a pretty impactful change. It's also it's explainable. So you can understand why it's making a decision, which is a problem with neural nets today. And because it's model-based, these models are sort of designed to be forever models. So in many ways, it's kind of the end state of AI as AI moves into this model-based paradigm that is not based on data and has the ability to be explainable and adapt to the world around it. Now, are these just fanciful ideas? No, they've actually been around for a while. This is an example of a system I worked on years ago. It was a biosensor capable of detecting and classifying any bacteria, virus, or toxin. And the key is, even if it's newly emerging or bioengineered, we didn't want to just detect things that were known, because viruses and bacteria, they mutate so fast that if you had a database of something, well, by the time you've implemented that, the virus has mutated so many times that it would no longer be detectable by a system that could just detect and classify known bugs. So this was something that was very, very challenging, and why the idea of adaptation or abstraction to things it's never seen before was paramount, and why the third wave of AI was needed. Interesting about this, there was no training data needed for this. And this has been deployed around the world, embassies, subways, post offices, very successful. It was the first to discover SARS, and because it's able to explain itself, it was able to classify that as a coronavirus. So again, wonderful technology, but it is right now somewhat confined to organizations that can have big budgets and are able to develop it and spend the time on it. This is another example where wanted to do the same thing that was done with the bugs, but do with humans. So you swab a doorknob and you want to identify all the people's DNA that's all mixed together and unwind that. Well, again, you're not going to have a database of every single person on Earth, and new people are being born. So to have something that could actually constantly stay up to date on that, we had to use a third wave AI approach where we didn't have any data, and we needed it to adapt to new people that are being born that we've never seen before. So again, this was capable of detecting and classifying any human on Earth, even if they've not yet been born. So again, this idea of forever models is a foundation of the third wave of AI. Now, I wanted to kind of try to explain just in the highest level. Now, there's huge gaps in what I'm explaining here, but I want to at least try and plant, because people often say, well, how can you do that? And I use this example from the Avengers, kind of the Marvel universe. If you ever watched, I think it was either Infinity Wars or Endgame, I don't remember which one. And the Avengers had a big defeat, and they were kind of, licking their wounds. And then they looked over at one of their kind of key partners, Dr. Strange, and he was sitting cross-legged, shaking violently. And they're like, what the heck's wrong with him? And after he's in a trance, and after he pops out of this trance, he says, I just saw every possible outcome, and I saw one of them that was the right answer that allows us to defeat the bad guy, Thanos. And in many ways, that's kind of how third wave AI operates. Again, much more detailed, making it a reality, but it's this ability to generate all the different possible solutions out there, such that at some point you go, aha, I compared it and I got a hit. And because these features now for each of these different dimensions were basically the inputs to this generative AI, parallel generative AI system, you now can explain, aha, this is the input, this is what I'm seeing. And so it becomes very explainable. And so again, this kind of ability to understand why an answer was made is very, very important to be able to really trust any of these new AI systems. So what is needed? Why isn't it here? Well, as I mentioned, the technology's been around for a while, but it's just confined to high expense development organizations. And so the thing that's missing is the ability to do generative AI in massive parallel. So in this example here in the upper right, if I want to detect that face, I need to be able to generate every face that could ever exist. That's a very big computational task. And again, the algorithms are amazing at actually achieving this, but it still needs more. So sort of whoever is going to discover this, and I'll say good enough third wave AI chip and a compiler that can do generative AI in parallel, they're going to control the market because, if you think about GPUs, they are good enough for second wave AI. And as most people know, NVIDIA is poised to become one of the biggest companies on the planet, if not the biggest. So with AI being so important right now and people having interest in it and the power of what third wave AI brings to the table, enabling that with these forever models, that's going to be a big leap ahead that'll probably turn third wave AI into a commodity. Now, why do I really feel this? Well, it's because I was involved in helping launch the second wave of AI through this very process. So second wave AI, these neural nets, a key component, mathematical component that is the most repeated operation, mathematical operation, is something called a convolution. And you just need massive amounts of it to train up a neural net, run a neural net. And what we realized 20 years ago was, well, GPUs, which are designed for the video game industry, they actually do one thing, convolution. That's all they do. They're really dumb, but they're low size, weight, power, and cost. And so it was a little parallel convolution computer. And all of a sudden we said, oh my goodness, this now takes an AI system, which might take 6 months to develop, down to train up down to a day. And so, or less than a day. And the companies I was working with, this was actually a DARPA funded effort. The companies that I was working with on this were ATI, which became AMD, and this other little penny stock company called NVIDIA. And so what was developed back then and the GPU really gave rise to neural nets becoming a commodity. And so we're in the same, there's a bit of parallelism that beforehand I needed convolutions in massive parallel. Now what we need for third wave AI, we need Gen AI in massive parallel. And I'm not talking about like having it parallel where everybody can run ChatGPT one instance around the world simultaneously. I'm talking about for a single sensor, a single location, running generative AI vertically at that one point, and then right next to it running parallel generative AI massive amounts. So it's a shift from, I think, how people are thinking of even Gen AI. But again, that solution there is going to be pretty monumental and a necessary development to really help make Gen AI, third wave AI a commodity, and why it's still a little ways out. And again, just to give you kind of a snapshot, the government is often a little bit ahead of commercial world, and these are some of the different applications out there that are utilizing third wave AI today. So again, big organizations with big budgets, they can be part of it. I was involved in that AI Navy active ship for its autonomous sub hunter. So it's out there floating around autonomously and navigating based on third wave AI techniques. So what's the impact of this? Well, I mentioned some of the attributes of third wave AI. And if you think about, in the upper left there, elimination of training data, my goodness, think of the global impact that could have. All the data management companies and tools, all that sort of goes away. Retraining and just training and retraining, that just isn't done. So the whole idea of GPU servers and all the compute needed to do the heavy training today, that kind of vaporizes. Security and privacy change. Without data, there really changes all the storage, both cloud and on-prem, because people's data isn't really worth anything anymore because these systems aren't based on data. Even AI ethics becomes sort of not obsolete, but reduced in importance because there's no data that you don't have to deal with protecting for security. So all the GDPR rules for protecting data are gone. Privacy issues kind of go away. Think of ChatGPT and what they're experiencing with all the usage rights. Well, that goes away because you don't need people's data to make these things work. And so, but most important is the idea that artificial general intelligence, the ultimate goal, that becomes closer to reality. And this universe of third wave AI applications really helps fill the gaps and expand what you can do today and fully realize. So when I think about tagline for the third wave of AI, the first wave of AI back in the 80s, that was when robotic process automation became popular, and we went into the factories and automated a lot of the factories with robots. That was the age of RPA, robotic process automation. If I think about in the tagline, what is third wave AI enable? It's the age of innovation automation. The idea of being able to invent things automatically that the world has never seen before. That really is amazing. And that's really what I would say the third wave AI kind of brings to the table. And to kind of drive that home, just a little anecdote. This is my last slide. I know I'm kind of running a little bit long here. I gave a talk up in Hollywood recently. That was a few months ago now. And it was on AI. And as I live in San Diego, and I was driving up to Hollywood and LA area, and I got a contact. They changed the venue location, and I showed up, and it was this little hotel, no signs, nothing there. In person, I finally tracked down someone in jeans and a t-shirt, and I was kind of whisked off to a small room, and there was video camera, and basically I was doing a live video presentation instead of a live presentation. And I guess now I didn't know what happened, but there were credible threats made against us, the speakers, due to a lot of the writer strikes and people that were very, very fearful about losing their jobs to AI. Now, what's funny is as I watched the different presenters before me, I was kind of the last presenter, the keynote speaker, and they all kept saying, oh, don't worry, don't worry, don't worry. AI is not going to take your job. Gen AI is just a stylizer. You still are the creative artist. You're the artist. So no one's going to take that away from you. And I believe that. I do support that for current AI. So for instance, as an example here, if you were to train up, let's say on the 80s, and you ask Gen AI to produce something from that data set, you still have to create that there's two palm trees, a girl in glasses, a sunset, but it will then stylize it in the style of the 80s. What it won't do is it won't create something completely never seen before. So, if it's all bright colors, clothing, it's not going to come up with dirty earth tone clothing. If it's perfectly manicured hair in the 80s, it's not going to come up with Kurt Cobain's unwashed, unkempt hair. If the music is bright and pop and major chords, it's not going to come up with a grungy minor chord, reverb type music. And so unbeknownst to me, I didn't realize hear the reason why we had moved until after I gave my talk. But I ended my talk with the neat thing about third wave AI is its creativity. So with second wave AI, you are the artist, but with third wave AI, AI does actually become the artist. Well, thank you very much. As always, I love dialogue with people, debating things with people. I love to be proven wrong. So, if there's anything in here that people have other insight, I love to discuss it with you because, that's the way we stay grounded and are able to advance this technology. So I'm going to hand it over to Erin Sutter, and she's going to touch on a couple additional topics about Dell here. So Erin, I'll just hand it over to you here.
Thanks so much, Bronze. Hi, everyone. My name is Erin Sutter. I'm a program manager for the Dell Expert Network. This is an affiliate program for MSPs and IT consultants, basically giving you benefits back for recommending Dell products to your end users. So there's 5 main benefits to joining our program. First off, you get access to a small business advisor. They're there to help with everything from order taking to quote building to answering any questions you may have. You also will get access to 2 different time-saving tools, Tech Direct, which will allow you to self-log support tickets on behalf of your end users, as well as Live Optics, which is a free vendor agnostic software giving you visibility into your end users' performance data. You'll also get access to our dedicated member portal. This is where you'll go to check your tier stats within our program, your Dell Expert Network rewards balance, as well as MSP-specific educational content. You can also earn up to $20,000 annually through Dell Expert Network rewards, which you earn off of all orders placed by your end users. And last but not least, it's a great way to consolidate billing. You can actually include your IT service fee onto the Dell lease agreement. That way, the end user only has to pay one vendor each month. So a lot of times I get asked, is my business a good fit for the program? So if you're a hardware reseller and you are seeing high margin from that, then I would recommend being in the partner program. Um, our program is really just meant for IT consultants and MSPs that are 100% focused on managing clients. However, there are some people that maybe aren't happy with hardware reselling. They're seeing pretty low margin in that. If that's the case, and that resonates with you, definitely reach out to me. We can have a further conversation around if Dell Expert Network makes sense with your business model. Here's just a quick picture of our dedicated member portal interface. That way you guys have some visibility into what that looks like from your end, but it's pretty user friendly. If you're interested in learning more, just want to see if our program would work with your business model, feel free to reach out to me. My contact information is up on the slide at Erin_Sutter@Dell.com. You can also reach out to me via LinkedIn. I have our landing page up here as well, www.dell.com/expert network. That being said, I'll go ahead and pass it back over to Brady so we can wrap this up with some questions.
All right, absolutely. Really interesting stuff. Thank you so much, Erin and Bronze. Before we kind of jump into the questions, Erin obviously provided her contact information. Bronze, if people want to reach out to you, interact, argue, whatever the case may be, where can they go?
Yeah, no, they can reach out to me directly via my email, which is just bronze.larson@dell.com, and we can set up time to interface, time willing, if I have the opportunities and the cycles, because it's always, to me, really, really important to hear from potential clients, customers, partners, colleagues, just to kind of understand what they're hearing out there. What are they seeing? What challenges are they facing? I mean, this networking is just absolutely paramount to staying on top and making sure that Dell is able to meet their needs. So I'd love to interface with people.
Awesome. And again, like I said, it was such a fascinating topic. I have a couple questions here. First of all, when do you think, Bronze, will be the next wave? When do you think the next wave of AI could become like more universal?
Yeah, so putting an exact date on that is always difficult, but there are companies, as I mentioned in my talk. I mean, I think the hardware advancement, the sort of GPU replacement, is probably going to be really the dominant shift that'll allow third wave AI to just become realized and more available to everybody. There are lots of companies out there that are working on different approaches to doing this. There's all sorts of accelerator advancement. Even within NVIDIA, they are working on some third wave AI type chips right now. And when those become cost effective and performance effective, that's when I think you're going to see a lot of different companies developing, using these chips to develop in a more efficient manner than they can today. My opinion too, when I talk about the changes to reduction in data, first wave AI has not gone away. It still meets a need. Second wave AI is not going away. It will still, there are applications where that just fits the need. So I look at it truly as more of a graceful transition rather than a sharp kind of direction change. So, I would probably put it within 5 years, you'll start to hear it more often. There's already some specific companies out there that are literally calling themselves third wave AI companies and are working specifically on this. And a lot of the large companies also have been working on this as well. So I'd say probably within the next 5 years, you'd really start to see third wave AI as a partner technology, right alongside the first wave, the second wave, and the third wave.
Really interesting stuff. Again, any examples that you have maybe of AI being a little overhyped?
Well, yeah, and it probably depends on people's opinion of what overhyped means. I mean, I think about when I'll use the drone example from the drone lab. I mean, I was very much involved in with commercial companies, and how do we deliver that technology so that packages can be delivered, food can be delivered, supplies can be delivered. And the feeling was, oh my gosh, look at these great examples, of a flight and showing a burrito being delivered. But when you really push that technology, you find that the error rates are just, they're orders of magnitude off from the safety requirements that are needed to make this technology available to people, let's say in cities, high density locations. That said, that technology for drone delivery is very useful in kind of rural areas and remote areas, the places in Canada, in Africa, in military and battlegrounds where you're less worried about the technology maybe falling on someone's head or something like that. There's just less chance of that happening. And I think about even that example with that Navy sub hunter, the active, the fully autonomous. Having a system like that operate in the ocean, where it may be the only vehicle within hundreds of square miles, that's quite different from an automobile operating or a drone operating in Manhattan. So that's where the kind of hype, sort of maybe, gets a little overhyped. Everyone says, oh my gosh, it's going to be here tomorrow. And, they don't realize, kind of the performance limitations and the places where it makes sense and the places where it may not make sense. And that is just so important for companies to understand, so that they don't spend large amounts of money investing in something that maybe didn't really, have the potential up front. And so I really encourage people to understand the limitations of second wave AI every time they approach a new project, because often with the right level of understanding and investigative work, you can sometimes rule out some prototype ideas before you spend a lot of money trying to develop it.
Okay, and speaking of understanding, you spoke a little bit about generative AI earlier on in the presentation. I think
Yep.
it's something that people are kind of gradually becoming more and more aware about. Could you talk about maybe some examples of what GAI is like really good at, and maybe some things that it's not so good at?
Absolutely. The thing that, so I've spent a lot of time in Gen AI over the years, and it is very powerful technology for various applications. But I think one thing that people don't realize, and it's maybe just a casualty of it being sort of put up against Google and Bing, it's kind of, people think of it as sort of a search engine. And it really isn't. It's just a stylizer. I got a whole other talk dedicated to real examples of taking art, Van Goghs and Monets, and training up to find the features of these artists, so that I can now create new content of a girl in a meadow, and then I can just say, add Monet to it, and it stylizes it like Monet, it creates stuff like that. And so because it's a stylizer and not necessarily a search engine, I'll use the example of software development. People will say it writes software. And yes, it does create software code. But what people have found out is the lines of code, the actual lines of code, are not up to snuff. It doesn't save time. So writing actual software, even though it does it, you kind of can't use it. But what you can use is the style of a software program. And what I mean by that is it creates the framework really, really well. If you have an idea you want to develop, Gen AI will outline all the components, put together the sort of system block diagram and how it's all should connect and what the different modules should do, because it understands the style of software design. But the individual lines of code, no, you have to do that. And I'll use an example, a personal one from last year. My daughter, she graduated high school, she's now in college, and she was a member of an organization called National Charity League that does philanthropy work. And at the end of 6 years of all this charity work and philanthropy work, there was a big dinner hosted, and I was to give a speech about my daughter for all the great work she did. And I said, well, I'm going to use Gen AI to help write my speech. And I had examples in there like, my daughter's name is Annalise. And I said, oh, Annalise, there aren't enough words to describe how proud I am of you. And of course, Gen AI came back with, I have nothing to say to you. There's no words. I said, with everything, although you're growing into a beautiful woman, you're still a little girl to me. And Gen AI came back with, why don't you grow up? I said, boy, you know, everything you've done, you really are the bomb. Now, it pulled information from the recent Oppenheimer movie, and it said, you remind me of Hiroshima, a destroyer of worlds. And so the speech was the silliest thing I've ever seen, but the framework of how it organized thoughts was actually wonderful. So I was able to take these examples and I turned it into a funny speech where what I wanted to say was the real speech, the things from my heart. And I told the chat GPT examples as kind of comedic, but it did actually outline a very nice speech in terms of how I should think through what I should say, how I should loop back. And so again, very, very powerful for stylizing, for creating structure, just the details. I mean, it's just pulling words from the top words that are out there on the internet. I mean, all ChatGPT is doing is predicting the next word in a sentence, one word at a time, based on the statistics of the internet. But the stylization, the style of Monet, the style of a talk, the style of it does a really good job at that. Hopefully those examples made sense.
Oh, absolutely. Very powerful, very explosive, I guess you might say, right?
Absolutely.
Aaron Sutter, the business development analyst, Dell Expert Network. I think this question is probably best suited for you as we kind of get ready to wind it down. This person wants to know how much it costs to actually join the Dell Expert Network program.
So it's 100% free to join. You just do have to meet the requirements of being our target audience, aka an IT consultant or an MSP. But those are really the only qualifications.
Oh, fantastic. So there you have it, completely free. And that's going to do it for the Q&A portion of this. And really, I think it's about time to wrap things up. First of all, I want to thank Bronze Larson, PhD, All Ecosystems Lead, Office of the CTO, Dell Technologies. Thank you, Bronze, for that amazing presentation.
Absolutely.
And thank you, Aaron Sutter, as I mentioned, the business development analyst for the Dell Expert Network. Thank you, Aaron.
Thank you.
And now, from all of us at Channel Vision Magazine, for Bronze Larson and Aaron Sutter, our good friends at Dell Technologies, thank you for attending. In the words of sportscaster Ernie Harwell, I think goodbyes are sad. I'd much rather say hello. Hello to a new adventure. Take care, everybody. Be good to one another.